Hey everybody, I'm Aaron Sweeney with Flex Machine Tools. We are over here at our G Series machine. This is a Cat 50, 35 horsepower, 6,000 RPM spindle machine. It's also a 20 foot long by 6 foot wide machine. And what we're gonna do today is we are running a potential customer's demo. We had a guy who's shown some interest in our machine and wanted to have us produce his parts. So he sent us some material. The material grade is A572 grade 50. So we have a couple pieces here that we're gonna put some bevels along the side. The customer actually sent in a chamfer mill that he currently uses that he wanted us to try to run on our machine as well. It's an inserted chamfer mill. And then the other thing that we're gonna do is we're gonna pop some holes on the top. We have an Allied Vortex drill that's 45 millimeter in diameter. So we're gonna run that too on the top, and we'll see how everything goes, and I hope you guys enjoy. So here we have the finished part. You can see we have the 5 holes that we drilled with the Allied Vortex drill, 45 millimeter diameter. And then we have the 2 bevels on each end, one on each end. They are 20 millimeter by 45 degree bevels. Again, the customer sent in the chamfer mill that we used to put those bevels on the part. We were able to get it all in one cut. We did have to play around with feeds and speeds a little bit, and also the direction in which we were cutting. So the customer sent in the material that was laser cut to a particular size. So therefore it left a heat affected zone all the way around the part. So the first cut that we tried making, we tried climb milling down the one side, and we got a lot of chatter, vibration, and we kind of thought that a lot of that was the insert coming into the hard surface on the heat affected zone. So what we wanted to do was conventional mill that would allow the insert to get up underneath the heat affected zone into the material and allow it to cut more smoothly, more freely. So we ended up making one cut, climb milling, and then we switched and went conventional milling. Everything sounded much better. We are actually able to get our feed rates back up to our commanded feeds and speeds that we were trying to achieve. And so everything came out great. Finishes look good. And anytime, that's kind of something that you have to do with every demo. If you're running a new tool, or you're working with a different diameter or a drill, feeds and speeds, you kind of have to play with it with different materials. So everything came out great, and hopefully the customer's happy. Give us a like on this video, give us a comment, and hope you guys enjoy.